So today we will practice on how to write our equilibrium constant expressions. So here's some of the reactions that we're going to practice with today. I have my K, which is my equilibrium constants, equals the concentrations of products divided by the concentrations of reactants. That's just the general form of it, or you might have seen in this form where the concentration of C to the power of C times the concentration of D to the power of D divided by the concentrations of A to the power of A times the concentrations of B to the power of B, and using this as your reaction symbol. And do keep in mind that you don't always have two products or two reactants. So we're going to go ahead and see how does that look like in the real reactions. First, I will start out by writing down my K equals all over. I will see what is my products or what are my products. In this case, it's H2O. Okay. And I'll put that on the top. Bracket H2O. And I will see if it has a coefficients greater than 1. Looks like 2 is our coefficient, so you go ahead and raise that to the power of 2. Divided by your reactants, which is H2. Coefficient is also 2. Divided by concentrations of O2. There's nothing in front of O2, so that means its coefficient is 1. So I don't have to write that out. You don't have to write out the 1. So this is my equilibrium constant expressions for these reactions. For the next reactions, I'll do the same thing. I just write out my K first. I have two products in these reactions. First one is NH4 plus. Okay. Go ahead and bracket that. And then its coefficient is 1, so I don't have to write that out. Next one is OH minus. Go ahead and copy that down. Okay. Its coefficient is also 1, so I don't have to write that out. Then go ahead and write down my reactants, which is NH3. Right. And then I have my H2O here. Coefficient is also 1, but I don't have to write that out. For this reactions, it's a little bit special because you have H2O, see this right here, as liquid form. So that does not get included in the expressions. So what you would do is cross that out. So that means your equilibrium constant expressions is actually NH4 plus times OH minus all over NH3. So that's something that I like to talk about next, is that it's really important to watch out for the gas phrases. Aqueous, liquid, and solid. Any pure solid or liquid is not included in the constant expression, the equilibrium constant expression, because it does not affect our K with its constant concentrations. Right? So if you look back into this reaction, you can see that gas, 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 there's no liquid or solid. They're all in gaseous phase. Here's our third reactions. Go ahead and write down my K equals all over. My products is H2O. Okay. Go ahead and copy that down. Coefficient is 2. raised to the power of 2 divided by H2 as my reactants to the power of 2 times O2, coefficient is 1. I can go ahead and ignore that. So if you've been paying attention, you can see that in this reaction, H2O is actually in liquid form compared to the first reactions where you have H2O in gaseous form. Compared to the liquid form right here. So that means you don't have to include H2O in this equilibrium constant expressions. Go ahead and write it out. And you can rewrite your expressions as 1 all over concentrations of H2 square times the concentrations of O2. Here's our last reactions. I'm going to write out my K divided by He plus coefficients 1 times the concentrations of Cl minus. Coefficient is also 1 divided by HeCl. Coefficient is also 1. So all of the coefficients is 1 in this expression, so you can just leave that out. So if you've been paying attention, again, you see that in this reactions, we have our HCl in solid phase. So that means you can go ahead and cross it out and rewrite your equilibrium constant expressions, which is equals He plus times Cl minus. You can leave it like that. So it's the same thing by saying these times divided by 1. Right? So why? Why don't we include pure solid and liquid? Because pure solid and liquid, they do not affect equilibrium constant due to their constant concentrations. So some of the notes that I took for myself to help me think about it is that you have gas molecules like H2O2 here. Well, gas, they're compressible. So gas is compressible. So that means you can have same moles of gas in different volumes. Right? You achieve that by compressing it down. And then next is aqueous. Well, aqueous is dissolvable in water. So that automatically affects the concentrations. Liquid is just liquid. Whereas solid, right, I like to think of it as having constant molar mass. And density. And that contributes to them of having constant concentrations. Right? So these are just some notes that I took for myself to help me understand why pure solid and liquid does not include it in the equilibrium constant expressions